as we talk about silver mining, refining and minting technologies, we have 3 presentations in this session. Presentation 1 is being taken up by Ms. Anamika Jha from Hindustan Zinc Limited. She would talk to us about silver mining and refining. T-Sinterment line, which is a new frontier in automated minting production, and this talk is being delivered by Mr. Julian Verdi of Tera Automation S.r.l. Best solutions and advanced technology for silver refining. Mr. Rajaram Phule from Rajesh India Manufacturing was supposed to be here for this presentation, but he could not make it due to some last-minute alteration. So somebody from his team will take up that presentation. Ladies and gentlemen, giving you a little bit of overview about Madam Anamika Jha. She leads the Pantnagar plant operations at Hindustan Zinc Limited, overseeing a key facility focused on value-added zinc and silver products. With strong experience in plant operations and industrial manufacturing, Ms. Jha drives operational efficiency, quality standards and process optimization while ensuring adherence to safety and sustainability practices. Her expertise spans large-scale manufacturing, team leadership and continuous improvement, contributing to company's leadership in global metals and mining sector. With this, let's invite Ms. Anamika Jha onto the podium.
I am Anamika Jha, as Ruchika very nicely gave an introduction. Since yesterday till today, we have been speaking about the market demand. So I would do a smooth transition from the market discussions to a little more technical discussions going forward, but not so that everyone in the house may feel alienated. So gentlemen and ladies, I would like to recall one of the incident, like when I was a child, my mother gave me a silver ring. And she gave it with the consideration that it was a recommendation for my zodiac. So from then till now, I have been associated with silver, you may say personally as well as professionally. When I was a kid, I didn't have that idea that, okay, what is the importance or why that ring? But now in the last 5 years, and as we have discussed yesterday and today, the way the shining metal has been, glowing even more. So that gives me a little more faith in how Hindustan Zinc has also a similar story like mine, has grown over the period of time. So in 1960s, when we started, people, it was primarily focused towards zinc extraction. Silver was only considered as a secondary metal. It was only in the 2000s that we changed the focus into a more strategic alignment, and it became a core value driver. Having said that, this has been the journey of Hindustan Zinc Limited. We have produced around 8,704 metric ton over the decade and a half, and that definitely is a big story for India. The entire, apart from the imports, this is where we contribute. I will speak a little more about that. Comparing the demands of the global demand and the Indian demand, while you might see that in the world perspective, there has been around 30,000 to say 32,000 or 36,000 maximum. A structurally stable demand has been there. This we also saw in the last few discussions that we had yesterday and today. What is important is to see how India has grown strategically, as well as a huge demand expansion which has ranged at different levels. The consumption pattern has evolved from 2021 till 2025, which I'll shortly show you. So the highlights being 2025, where we are talking about the industrial application usage. Before I go there, this is where I was talking about that the contribution of India, India's demand from Hindustan Zinc perspective has been close to 8 to 10% of the total imports that we do. So definitely looking forward to increase this from 8 to 10% to further in the upcoming future. The exact thing, the annual growth that we spoke about, if you see from 2021, wherein it was more focused towards jewelry, it moved towards the photovoltaics in the next 2 years, and then the annual growth rate has increased tremendously for the advanced electronics, the data centers, and the various 5G infrastructure that we are expecting to grow in the upcoming years. So that is one of the annual growth story year on year where we have seen a tremendous shift in the requirement, in the understanding of the investors, of the general retailers and public. Talking about Hindustan Zinc in specific, there are 3 pieces to it. This Hindustan Zinc, as it is an integrated mining to metal producer, one thing stands out is the geopolitical shield that it provides in terms of the production. When we talk about, we source our ores from 4 different mines, which is Sindesar Kurd mine, the Rampura Agucha mine, Dariba and Zawar. And from there are 8 stages from mining to the production of the casted metal that we see. So the 8 processes that are followed to produce all of that happens, ladies and gentlemen, in-house. This also gives shield, I would say, in terms of volatility because we are not dependent on the international concentrate and the geopolitical conditions that we had very recently, the disruptions that is there. That also provides a shield to us, which helps us to maintain the production to a certain number, which happens to be around 600 to 700 tons annually. What I want to talk about when I said we have 8 stages, so going a little bit technical, so all those 8 stages starts with ore extraction, moving on to the grinding and crushing, and then there is a beneficiation, which is the enriching of silver. From beneficiation, it moves on to the next stage of roasting. So the first 3 stages mostly aligns with the mining. Then we move to the smelting processes, the roasting, the pyrometallurgical processes, the hydrometallurgical processes, and then to the electro-refining process, which gives us 99.99% purity silver. The casting from this electro-refining process, the casting that happens is of 30 kg bar that you must have seen next door put at this stall of Hindustan Zinc. So the 30 kg bar production takes around close to a cycle of 15 to 18 days. Slightly going towards the purity when we speak about the electro-refining, it involves 3 parties. One is the cathode, the anode, and the electrolysis, the electrolyte. So the electrolysis involves, we have the anode, which is slightly impure silver, from which the crystals are formed on the cathode, which is the crystallization that you see. And those crystals are melted in a furnace and casted into 30 kg bar. This 30 kg bar is LBMA certified, and the entire process helps us to reduce the losses, which may be in terms of the melting loss or the recycling loss. We have a recovery of over 99% if we talk about the refining per se, and that is a good number. I would also talk about slightly as to how we want to improve overall recovery over the period of time that we are looking forward, considering the sustainable development, not only from the primary metal perspective, but also the secondary, that is the recycling. When I said that, the net zero, when we are producing, the part of there is a refining that is happening at Pantnagar Metal Plant is sourcing 100% green and renewable energy, which means that all the product that is made is green. However, there is a part, the rest of the processes, the integrated processes that is happening at mines and mills and the other smelting processes involves 70% usage of renewable energy, which we are looking forward to increase further in the coming 5 years in alignment with our net zero goal. Also, like I said, the recycling piece, has taken up, there was a discussion earlier in the morning as to what are the processes that we are using and how important is recycling of the scrap. So all the waste that has generated during the smelting process and in the mine tailings, we have started recycling them. And I'm very happy to share that last year we had done around 20 metric tons of recycling, which added on to our silver production of this year, this financial year, which again, going forward, we will be increasing by different methodologies that we have adopted. And definitely, yesterday there was again one discussion that silver is going to be the future, and Hindustan Zinc Limited is committed towards increasing the production such that with least amount of recovery losses, such that we are able to increase our share of demand that we cover and that we cover domestically and hopefully internationally as well. So thank you to everyone for listening.
With this, it's time for me to invite our next speaker. Please put your hands up for Mr. Julian Verdi as he takes up his place on the podium.
Thank you for being here. It's a pleasure and an honor for me to show you something new from Italy, a long way from India, but technology has no borders. And so thank you for anticipating my speech. And ladies and gentlemen, thank you. All right, so today we're going to present a new system for making minted products, basically coins and bars, starting from a raw material which is pure silver, 49 silver, but in the form of atomized powder instead of the traditional plate. This is possible thanks to the support and contribution of ABC Bullion, well-known Australian refineries, Italimpianti, Orafi, and Tera technology. Briefly, I show you who we are. We are a group of company located in the center of Italy, close to Florence. And Italimpianti has 50 years of expertise in the manufacturing and designing of precious metal equipment, recovery, assaying, refining, all gold, silver, PGM, and connected metals, plus a division for engineering and robotics thanks to Tera Automation, which has joined the group and is specialized in the design and the manufacturing of cast furnaces for making cast bars, and all connected to refined metal production, so bars, coins, and grains in standalone version or automated lines. The index of this presentation will start with a description of the traditional minting process. Then we will introduce the new minting process we call sinter blanking and its phases and involved equipment. Then we will jump into a comparison between the two processes and try to focus on the key features and advantages of the new one, and then we will show you some pictures of finished products. So in the traditional process, of course, everyone in the room is aware about this. We start producing by casting a plate of fine silver. This plate, once it has been casted through the continuous casting or manual, whatever, we need to brush it or sometimes even to mill the surface to get start with a super shining plate, and then we go into the rolling step where we want to reach the desired thickness to make our finished product. So we go in a primary reduction with a rough hew and rolling mill. Then we need to anneal because the silver will get harder and harder at each roll. So with these alternate steps, we go through the finishing rolling mill until we get a very precise, calibrated, shiny silver strip. At this point, we cut this shear to the width we need for making the blanks. We blank, we cut the strip into blanks, and then we check the weight. If we are making coins, we might want to make a rim. Then we do the tumbling, finishing, of the blank. At this point, we can go into the coining press and make our beautiful coin or our beautiful bar. So these are manual processes. In the new technology, we have replaced part of these manual processes with automation. How is this possible? So in the new process, we start with casting, like in the traditional, but instead of casting a plate, we cast some powder. This is possible using a water atomizer in our case, from which we obtain a very fine powder of pure silver that will be then dried and selected in its thick diameter by sieving. And then with this raw material, we go into the automated production by sintering of our blanks and coins. This is an example of a water atomizer that is working. So in the open air, we melt the metal in a traditional tilting furnace. Then this metal is poured into a tank where a very heavy water jet will invest the metal as it drops to the bottom. And thanks to this high pressure water jet, it will be pulverized. We will get a very fine powder at the bottom of the container. This fine powder will be then recovered, washed, dried, and sieved. Of course, all this has to happen into a proper extraction environment to recover any, particle of silver which may fly out. So at this point, we have our beautiful powder selected and dry, and we go into the dosing step. We have designed a 3-head dosing machine that can produce simultaneously the requested doses of powder. So in the case, it can be 1 ounce. If in the video, in the presentation, we are focusing on 1 ounce round silver. The dosing is prepared by the dosing machine. Then a robot will pick the container with the exact amount of powder and pour it into the preforming press where it will be compacted. So here you can see an overall view. This is the station where the dosing is, the powder is dosed. This you see in the render is a double line. When the dose has been made by the dosing machine, a robot will transfer it into the compaction press. At this point, the same robot will pick the preformed blank and place it into the sintering furnace. At the exit of the sintering furnace, video of this render. Yeah, this is the real installation. It is currently working in Arezzo, where this video has been taken. So here you can see physically the machines, and these are the dosing units, the robotic cell that manages the blank handling, the sintering belt furnace, and in this case it's ending here, while in the video we also have added in the render the rimming station at the end and the minting station. So here you can see the robot while it works. So in this case, the blanks are recovered from the preforming press and placed into vessels, from where later on the operator will go into the sintering furnace. So these are details of the design of the equipment. All this has been produced in-house by Tera and the Italian Impianti, as I was explaining to you. So this is exactly the moment when the robot pours the powder into the compacting press. The press is a traditional 4 columns hydraulic minting press. In this case, I think it's 100-ton power. We make the shaped blank, and then the robot puts it into the sintering furnace. At the exit of the sintering furnace, the blank will be ready for minting. So we skip totally the tumbling, the washing, and those steps, while if necessary, we still go to the rimming and edging of the blank if it is necessary. This line can be as flexible in terms of the sizes of the items. You only need to change some tooling, some dies. can make ingots as well as coins, and can produce gold items also. Then, going ahead, we were at the sintering furnace. Then at the exit, if we are making coins, we have an edging machine, edging with a rimming machine, and the robot that will transfer the ready blank to be struck to the minting press, also equipped with a robot, if you like. This is, in fact, the RoboMint, the final station. That is, of course, also a standalone module. So you can even use this only manually loading the blanks into the feeder. And this is a catalog piece of equipment from Tera for some years, where instead of having an operator to feed the minting press, you can preload a large number of ready blanks and just press start and let the system work even overnight if necessary. And of course, with some benefits in terms of consistency and quality of the finished product. Of course, all our systems are available on a manual basis or automated basis, and at the same time, for each equipment or line, we provide a live data collecting system for analysis and maintenance. So this is a full automatic line. No operators are involved here, probably one supervisor, while, of course, we are very aware that in the traditional, it is mainly fully a manual process. In terms of numbers, less than 50 square meters, 6 to 8 pieces per minute, works 24 hours, 7/7, and we can reach 2 million pieces per year on the 1 ounce silver round. So, a quick comparison. Traditional, we start with a plate, and we know there are many works involved to reach this condition. Having a very calibrated and shiny strip requires time, energy, operators. While in the new process, we basically start with a powder coming from one melting step. So in the traditional, we have a total of 11 steps, 2 melting, 8 mechanical, and 1 finishing. In the new, we have 6 melting and mechanical steps. So in terms of time and operators' resource, there is a huge difference from the two systems. Another key point in this evaluation is the scraps. So we are all much aware of the high percentage of waste we get from the traditional process, which then needs to be remelted and eventually even refined again. In the new process, the only tails we have are coming from the sieving of the powder. So we want to remove the too tiny particles and the too large, and the goods we go for the production. In terms of number, of course, this means saving a lot of energy. But in terms of number, here you can get a very easy understanding that in the traditional, to make 100 kg of coins, I need to involve 300 kg of metal. In the powder process, for the same quantity, I need to have 180, less than 20 kg more. So these are the key advantages. We have, of course, less stock material, for the reason I just explained, which translates into less capital investment, less scraps, and the procedure has a very compact footprint, much lower human operators interaction, and a quicker time to market. Quality of the items is totally flexible in terms of sizes and design. You can easily obtain incredible high relief results and improve the quality of the finished product. Of course, each mint has then its internal R&D and can work on the powder blanks to try and get the maximum. So we are in line with the ESG standards for energy saving, reduction of the space, and reduction of the raw material. And these are some samples of the finished products. So even for the World Money Fair in Berlin in February, we presented the 1 kilo coin made by powder and a set of bars which are stackable one with the other. You can see the high relief in these 1 ounce silver and different designs, sizes of bars. And again, you can appreciate here some details about the relief and the shining of the finishing of these products. So this is our small revolution in this business, and of course, it is possible to see this working in Arezzo if you ever have the chance.
Well, ladies and gentlemen, first a round of applause. I can already see a lot of interest and intrigue on a lot of faces out here. Please take your seat up there. And with this, I invite our final speaker for this session, talking to us about best solutions and advanced technology for silver refining. We have Mr. Shailesh Singh on behalf of Rajesh India Manufacturing.
It's been wonderful over here in Dehradun for a Silver Conference 2026. I would like to say thank you for giving this opportunity to me. And before I would like to tell you something that our Managing Director, Mr. Rajaram Phule, couldn't able to make it for this session. So on his behalf, I'm gonna present our Rajesh India Manufacturing Private Limited. So before I begin, I would like to introduce our Sales Director, Mr. Amol Bansode, who is present with us today. He brings an extensive hands-on experience in precious metal refining, plant execution, and process optimization. He will be supporting this session by addressing the technical aspects and the query during this session. Now I will take you through our approach, our best solution and advanced technology for a silver refining. So today we are going to give the presentation focusing on advanced technology can transfer silver refining, make it safer, more efficient and environmentally responsible. At Rajesh India, we provide end-to-end refining solution globally. In this presentation, I focus on key source of silver refining, industry challenges, and the advanced technology used to overcome them, which is particularly highlights safety and emission control. Second slide says that source of silver in India. In India, the large portion of silver comes from recycling sources such as old jewelry, temple silver jewelry, industrial scrap, e-waste, and many others, etc. So this material contains multiple impurities, making refining both complex and critical. Industry today this is the second slide, fourth slide we have it. Industry today faces several operational challenges such as toxic emissions, low recovery efficiency, environmental compliance pressure, safety risks due to a manual process. These challenges directly impact both profitability and sustainability. And also, one most serious concern is the generation of hazardous fumes, cadmium, the lead and zinc vapors, acidic gases like NOx. Without proper control, this poses a significant risk to both the workers and the environment. So for this, we have advanced technology. To address these challenges, the advanced technology is essential. It ensures a safe operation, better emission control, and high purity and recovery. The most significantly, regulatory compliance, which we follow. And the advanced solution, such as scrubber system for the gas treatment, ETP system for the wastewater, automation for process control, and enclosed system for operator safety. This creates a full control and efficient refining environment. Moving ahead with the 8th slide, we have silver refining machine. Our silver refining systems are fully integrated, covering melting, chemical refining, metal recovery, and pollution control. This system designed for a continuous, safe, scalable operations. This is a scrubber system which helps to neutralize the gases. We have effluent treatment plant which help us to the wastewater treatment and discharge of water accordingly. We have a manufacturing silver jewelry process, which means we use this combination of advanced pollution control technology, such as dust collectors and the bag filter for fine particles, the wet scrubber for gas neutralization, and the resin recovery for a value extraction. This ensures the clean emissions, over 99% particle captures, and full compliance with environmental norms. We have a process flow chart, which the refining process flow are structured and controlled flow, such as raw input, processing, recovery, and final input. We achieve 99.99% purity, byproduct recovery, and zero waste discharge. Statutory compliance. So we follow a complete statutory environmental compliance. Our systems are designed to maximize the value, high recovery even from a low-grade materials, consistently purity, scalable production capacity. This directly improves our operational profitability. At Rajesh India, we focus on the three key pillars: safety, compliance, and a commercial performance. Our solutions are engineered to deliver long-term sustainable result. And the last, to conclude, the advanced refining is not just a final output. It's about our responsibility towards the people, environment, and the business sustainability. At Rajesh India, we are committed to delivering the solution that are advanced, safe, and sustainable. Thank you for your time. We are happy to take your questions. Mr. Amol and I will glad to assist you. Thank you.
All right. So with this, we conclude this session. And a big thank you to all our presenters up here.